Hello, good morning, good afternoon, and good evening to one and all present here. Hope you all are doing well. We welcome you to this first series of World Conference on Information Systems for Business Management. This series is an extension to our ICT 4SD series, and initiating this series, we believe that this doesn't happen overnight but leads to a brand. Today, this conference is joined by delegates of more than 11 countries in this digital mode. I request all to keep your mic on mute mode so that it will be easy for everyone to listen to the speakers. To start with the formal session, I would like to invite Dr. Amit Joshi to address the inaugural session. Dr. Amit Joshi, he is the organizing secretary of ISBM 2022 and the director of Global Knowledge Research Foundation. Apart from that, he is the director of Knowledge Chamber of Commerce and Industry. Furthermore, he is the chair of International Federation Information Processing, IFIP. Dr. Amit Joshi, over to you, sir, for your further address.
Thank you, Anisha, and a very good morning, good afternoon, and good evening to one and all present here in this occasion. This conference started yesterday, and we had a very fantastic session in Bangkok yesterday. I think half of the participants joined there in physical modes, and for the people who were not able to join, actually, we have kept this digital session for them. So I welcome you all on this great morning from Thailand. And I welcome Dr. Tuba, Dr. Narendra, Dr. Chakchai, as well as other guests who are here, Dr. Day, who will be just joining. So I'll welcome you all to this first edition of ISBM 2022, which is Information Systems for Business Management. So this series we have started with an extension to our ICT for SD series. When we were doing this ICT for SD conference in India for almost 7 years, we realized that there were few themes which were not intercepted through that conference, which is core areas related to how to process that information regarding the business management of that systems which were generating information, and the analytics the information is providing for many of the researchers, many of the big companies to process their data. So this is how this conference came into existing, and we thought that this will be a booming subject in times to come. So we initiated this conference, and there will be no other good place like Bangkok where it could be, because travel is now open, and I wish that we all of you would also have been here, but let's plan it for 2023 that we all meet in physical mode in Bangkok. And regarding the conference, I think this is the first series of ISBM, and we have received almost 350 papers of around 27 countries. Out of the peer scrutiny and peer review, we selected 57 odd papers for this first edition of the conference, which comprises of 14 to 16 countries authors. So I hope this is a good acceptance rate with a good reviewing criteria, and I again hope that this conference will prove to be right path-breaking conference, where the actual researchers who are doing their research on business analytics with information systems will definitely get a boom over it with their research. I also would like to quote here that we have been organizing conferences across the globe. We have few conferences in London, but the biggest challenge a conference organizer or a technical program committee of a conference faces to get the papers reviewed. So this is again a challenge for us as well, and we try many times to just take care of that very effectively in various phases. So our review process consists of 3 to 4 phases. It's just for the information that because this is important that how we select papers. This is really important that how we select papers and what kind of content we are producing through our conferences, because that is going to definitely differ in the world, in this competitive world. So I thank all the authors who have contributed and who have trusted in this conference in the first edition itself, and really hope that things will definitely change. Those authors who have not been able to join here physically will be there for the next 2023 edition, and I wish that the deliberations which will go on today in the technical sessions, because I think there are 8 technical sessions planned today. Also, there were some digital sessions yesterday, some physical sessions yesterday, and today also there are 8 to 9 technical sessions. So I think people who have authors who have interest in their own core areas, you can just check on the schedule in our website, and you can just log into the system to listen to the presenters and try to make a connect. At least one connect in one conference will definitely change your research thought process, that how competitive world and the people from other parts of the world are doing their research in their own ways. So with this, I wish everyone all the best for their future endeavors, as well as the presentation today for the conference. And I welcome our guests, Dr. Tuba, Dr. Narendra, Dr. Chakchai, and Dr. Day. And I again respect very much Dr. Tuba, because he is awake very early morning from the US. So it's very harsh time there. It will be around 3 or 4 o'clock in the morning. So thank you, Professor Tuba, for being here. And I look forward to the deliberations as well as the talks by the speakers this morning. Thank you very much.
Thank you, Amit sir, for your kind words. Moving further, I would like to invite our first speaker, Professor Milan Tuba. Professor Milan Tuba is currently the Vice Rector of Singdanum University, Serbia. His research interests include mathematical queuing, theory, and heuristic optimizations applied to computer networks, image processing, and combinatorial problems. He is the author of more than 150 scientific papers and a monograph. He is also a co-editor, member of the editorial board, scientific committee member, and a reviewer for several international journals and conferences. He is a member of various international and scientific organizations, ACM, IEEE, AMS, SIAM, and FNA. Professor Milan Tuba, welcome to the session, sir. Over to you for your further address.
Thank you. Good morning to all participants of this conference. I'm glad to be here. It's honor and pleasure to be part of this conference. And as Dr. Yoshi mentioned, this is the first edition of this specialized conference, but also continuation of the more general 7th edition of the conference that has a long tradition already. And I hope that you will all gain many benefits from exchanging research idea and doing social scientific networking here. It would be probably more interesting if we were all present in Bangkok now, but for different reasons, some of us have to do it this way, online. For the last 2 years, it was almost the only way to do conferences, but now fortunately it's possible to do regular conferences, but still there are these sessions. As Dr. Yoshi mentioned, I would rather be there, as I have been many times in Bangkok before, but this is a specific situation where I moved to United States, to Texas, and for the first 2 months, it's more difficult for me to travel because I have too many everyday things here to handle, from apartment, a car, even driving license and things like that. So I was not able to travel at this time, but fortunately the time difference is exactly 12 hours. So it's not so bad time here. It's 11 o'clock in the Bangkok, it's 11 o'clock here also, but 11 o'clock before midnight. And I'm sure that next conference, not only in Bangkok, but wherever the next edition is, that I will be able to be present there physically and meet with everybody and talk and do whatever conferences are good for. So now I would like just to mention a few words about the specific situation that we are experiencing right now. of course, the situation is specific in many ways. This is unique times. So we had 2 years that nobody remembers anything similar in our lives. And then immediately after that, we have again a war, and we have many things besides scientific research. So it's somehow putting in shade this unique situation in science, that now we are making a revolutionary progress, which really has enormous repercussion to everything, not only to science. In general situation, we have different scientific areas, researchers are doing research, things are progressing, and everything is fine. Occasionally, something happens that really is revolutionary in science, but then it also shakes the whole world. So we remember a few things like maybe smartphones or internet or PC, things like that happened in the past. Most of those things were in the area of computer science. Before that, of course, we had steam machines and things like that, but it was happening much more slowly. And now we have one such situation where we should be aware of that. It is a great research opportunity because there are so many uninvestigated areas. So it's good and in some sense easy to be a researcher because sometimes, you know, if you have some area that almost everything is discovered, then you need a lot of effort to find that last piece that is missing. Here it's open field, like Wild West. Wherever you go, there is something, and you will find some kind of gold somewhere and be able to publish it. And that area is, of course, artificial intelligence. This conference is about business management. Some conferences are about smart cities, about many divorces. It can be, you know, about medical diagnostics, about agriculture, about whatever. But last couple of years, it's almost certainly that these buzzwords will be mentioned. It starts with artificial intelligence and goes to deep learning, data mining, machine learning, and specifically to convolutional neural networks. But those previous things are more general. So it is interesting because first, it applies to all areas. It is a very general technique, like we had optimization before. So anything is optimization. If you are doing agriculture, you're optimizing something. If you are doing medicine, you are optimizing something. If you are doing transportation, you are optimizing something. Now, similar thing now is in artificial intelligence, we have classification problem, where we simply have to determine if individuals from certain population belong to one group or don't belong to that group. And then, of course, if you think about medical diagnostics, you have patients, and then you have to do classification. Which disease each patient has? Does he belong to the class of brain patients with some abnormalities on the brain, or kidney, or what kind of abnormality on kidney, and so on. And then you may look at something completely different, like autonomous vehicles, cars without drivers, which has nothing common with medical diagnostics or with agriculture or with some other areas. But actually, they are using the same artificial intelligence techniques, because driving a car without a driver is actually introducing many sensors, most cameras, front, rear, left, right, and then maybe ultrasound sensors and things like that, collecting that information, and then in real time looking at the obtained data and making decisions. So, for example, from camera, you get a moving image. Now you get a slice, a static image, and in that image, you have to do classification. Do I see in this image stop sign or not? Do I see pedestrian in this image or not? Do I see speed limit sign or not? And then based on that classification, you take further actions. If I see stop sign, then I apply signal that will do braking, or if I see pedestrian or another vehicle, then I apply signal that will turn the wheel or maybe slow the vehicle or whatever is necessary. So we have that mechanical part, but most important is this artificial intelligence part, which is again, driving a car is a series of classification decisions, but huge number of such decisions every second based on thousands of different signals. So it is computational very intensive. So this classification really is the basis of all this revolution that is happening. And for classification, we had a number of different methods. So let's say 15 years ago, support vector machines were very popular. They were a powerful new technique. Before that, we had other techniques and so on. And we were making improvements and comparing those techniques. So interesting example is that today we use a handwritten digit recognition as a benchmark case. 30 years ago or 25 years ago, it was a very interesting practical problems, because for sorting checks in banks or for sorting envelopes in the post office based on zip code, both written by hand, which is a difficult task. You could automatize those procedures and it was very beneficial. So it was a practical problem. And University in California collected a huge number of handwritten digits, posted them as public database. And since then, researchers in that area use that as a benchmark case. So whenever a new method is developed, we use that MNIST database of handwritten digits to test our new classification method, how good it is. And for decades, what was happening is that we had slow progress. And then we had top researchers thinking, spending months, developing new methods, and then having small improvements. So we were going from 98 to 98.5 to 98.8 to 99, 99.1, and so on. So for many, many years, with a lot of effort, many months of top researchers' efforts, we were slowly improving those results. Today, we are in the situation that we have publicly available software tools, and we also have a lot of computational power, mostly through graphical cards, because those are the most powerful available computing devices. And what we do today routinely is that for undergraduate courses in artificial intelligence, in one lesson that is 45 minutes or 1 hour, we develop a convolutional neural network that is dealing with that same problem, MNIST handwritten digit recognition. And the result of that 15 minutes effort is always accuracy better than 99%. So that shows what kind of revolution we are witnessing. For decades, we had top researchers putting months of work to make slow progress below 99% and going 0.1, 0.2, improving accuracy. And now any undergraduate class in one class, 45 minutes, develops a convolutional neural network model, which is certainly better than 99%. And then next class, you can try to improve it and change few things and then make it from 99.1 to 99.2, 0.3. And then depending how advanced the class is and how much effort you put into that, you go even higher. So that really shows that it is not a regular situation. It is a revolutionary situation. What was a miracle 10, 15 years ago is now routinely available for undergraduate classes. And that shows that it is interesting time and that we as researchers, especially young researchers, can select topics and be sure that they will make fast progress. in travel area, in business, in electrical power systems, in transportation, whatever area are you working in, you just look what has been done before, you apply these new methods, and you will certainly get better results. So you don't have to worry that it will take 3 years or 5 years of research to maybe make something a little bit better and maybe not be successful. The situation is such that you are practically guaranteed that you will be able to improve anything. So that is very good for researchers. But it is also dangerous in a sense that the change is so big that, of course, it can also be misused. The question is how you use those systems. If you try to make better medical diagnosis, you will be able to do that, and that's good. But then you can use it to collect data. A lot of data is available now about everybody. With the smartphone, you are sending millions of data about you every day, about your location, about your heart rate, about your pace of your step, about who knows what. You are not aware what you are sending. And for millions and billions of people, that information is available. And based on that, you can make so powerful software tools that you can predict anything. You can know about everybody more than they know about themselves. So you can manipulate elections, political processes, or do all kinds of things. So these tools are very powerful, and because of that, then we have also a philosophical, political problem how to deal with that. In some sense, it can be compared maybe with Nobel discovery of dynamite, and then later his Nobel Prize, where of course his idea was to make the world a better place, and with dynamite you can build railroads and whatever, you can move mountains, and man will be more powerful against nature. But then of course that same dynamite can be used for wars and make very destructive artillery, and of course you know the rest of the story. So if the situation always, if there is something very new and powerful, it can be used in different ways, and that is a topic that has to be discussed. And also there are few other problems or well, topics that have to be discussed from different points of view, and that is that we don't understand these systems. They are in essence black boxes, and they are very powerful. You just feed a lot of data, and they give very good results. So that is good. But since we don't understand how they do it, it's dangerous. So sometimes they make errors, and then we are very worried because we don't understand how they were processing that data and came to that error, and how to avoid that happening in the future. And the problem is also philosophical, because it seems that in essence, it may be impossible to solve, because those methods are very powerful, because they don't rely on human. Human is limited. So if you include human, you have to limit the number of features and data. If you want to understand something, it cannot be very complex. So as long as you can understand it, it's rather simple and not powerful. If you make a model that is very powerful, it will certainly be beyond human understanding, because instead of 10 or 100 features, for example, for medical diagnostics, you can you use data like what is your skin color, how about your nails, how about your eyes, and then you go to deeper features like number of red blood cells, white blood cells, blood pressure, and so on and so on. So we get, let's say, 100 or 200 features, and then we understand what these features are, and we make diagnosis. Here you can feed a lot of data about everybody, and you can have millions of features. Features that seem completely irrelevant, like shoe size, like how often you buy shaving lotion, whatever, anything about your life. It looks ridiculous, but you don't know if it can be useful. So you feed all that data. The system uses million features and get better results that any human can do. And you don't know why. It may be because of your shaving lotion pattern, which is very strange, but who knows what kind of information can be hidden there. But it can be about many things that we don't have names of. If you have million features, you cannot invent million name for different features. So it's something very, very hidden in the data from us. And that is what gives power to those systems. So it's a interesting situation, as I say, not only from the computer science point of view, but philosophical and political, that you have very powerful system, how you use them and how you deal with situation that it is difficult to understand how they work. So as I say, it's very interesting time. So for researchers, of course, I hope that everybody will use this conference to best and make networking and future collaboration and do research. And that research, of course, helped with these new technologies will certainly be successful and hopefully will come to some better place. And of course, hopefully next time we'll all be online with conference dinner and walk in the city and all other things that are essential for the conference. Thank you.
Thank you, Professor Tuba, for your knowledgeable address. Artificial intelligence is certainly very powerful in today's time, and we are curious to see how it grows and impacts in the future. Moving further, we have Professor Narendra Londe. Dr. Narendra D. Londe is presently working as Associate Professor in the Department of Electrical Engineering of National Institute of Technology, Raipur, Chhattisgarh, India. He completed his BE from Amravati University in 2000, followed by MTech and PhD from Indian Institute of Technology, Roorkee in the year 2006 and 2011, respectively. He has 14 years of rich experience of academics and research. He has published more than 150 articles in recognized journals, conferences, and books. His main areas of research include medical signal and image processing, biomedical instrumentation, speech signal processing, biometrics, intelligent healthcare, brain-computer interface, artificial intelligence, and pattern recognition. He has been awarded by organizations like Taiwan Society of Ultrasound in Medicine, Ultrasonics Society of India, and NIT Raipur. He is an active member of different recognized societies from his areas of research, including senior membership of IEEE. Professor Narendra Londe, welcome to the session, sir. Over to you for your further address.
Thank you. Thank you, Anisha, for the introduction. Very good morning, good afternoon, and good evening to everyone. I'm really happy and honored to be a part of first edition of the World Conference on Information Systems for Business Management. I thank Amit Joshi and team of GR Foundation for inviting me to the inauguration session. I'm also honored to share a dais with the dignitaries like Professor Tuba and Professor Chakchai. Regarding the theme of the conference, I have a quick view on the sentiment analysis that I want to share to the invitees today for the inauguration program. Somewhere, as this conference is related to the business management, what I feel that as an AI scientist, the application of the artificial intelligence is booming in all the fields, but particularly in businesses also it is highly being utilized. For the businesses, very important component is the client, customers, right? So those customers, those clients, what they are having the opinions about the products being offered by the business companies, okay, or what are the services being provided. They are having their opinions, they are having their judgments, and those judgments and those opinions they are expressing somewhere, okay. In the today's digital world, they have many means of expression. There are many platforms to express their these judgments and opinions about the different products and the services. So the business, whatever the industries, business industries, they are minutely observing those sentiments of their customers and the clients, and with the help of the artificial intelligence, they are assessing their sentiments, and they, based on that assessment, they are improvising their products, they are improvising their services, they are understanding the requirement of the customers, they are understanding, they are even modifying their products, their services as per the suggestions from the customers. Now the thing is that it was earlier very difficult that to find where what customer wants to say, what clients wants to suggest, okay. Going individual customers and the clients was difficult for the business industries earlier, but nowadays as all these opinions and the judgments or the suggestions are being posted by the clients and the customers, or the customers over the internet in the form of, say, blogs, writing the tweets, writing posts, okay, on social medias. So based on that, with the help of the artificial intelligence, those sentiments are being analyzed and they are being used for the benefit of the business. So what is this sentiment analysis? Is basically, the sentiment analysis is actually a process where actually the text or text are being analyzed, which is being posted by the customers for identifying their opinions and the judgments. This procedure actually has this procedure is actually involves that to understand those texts and to arrive at the gist of that particular suggestions of that particular text, whether it is positive, negative, or it is neutral, okay. And this sentiment analysis is then being used to analyzing this text being put on the social medias, or they are being news, or the forums, or some people are putting the blogs. Even now, whatever the reviews are being posted by the customers or the clients in the form of the videos like YouTube channels, okay, that is also being analyzed and for bettering the products and the services. So just like an example, say that somebody is watching, or somebody has watched a movie and is expressing that the movie is fabulous, okay, or some particular actor is acting in that movie, okay, or that movie is horrible. So this opinion or these suggestions is actually motivating others to whether to see that movie or not, and the people, those who have produced that movie, they will be understanding that whether our movie is good or not, or what kind of problems were there with the movie, okay. So these opinions, these suggestions, or these judgments are really important today to make better products, make better services. Now, what exactly that we learn into this sentiment analysis? Basically, we find out the sentiment polarity, okay. Technically, when as an AI scientist, what exactly is involved that I want to express is here in a very brief, in a brief, that the overall sentiment is actually expressed as a paragraph, or it may be in a phrase or a word. So that is what we call as a polarity. This polarity is actually measured using a sentiment score, and that sentiment score is actually gives us an understanding whether that sentiment is positive, negative, or it is neutral. What exactly there are two types of flavors that we search in the sentiments. First one is the explicit, that subjective sentence directly expresses an opinion. So say that somebody is saying that it is a beautiful day, all right, So this is an explicit expression. Likewise, there is an implicit expressions also where the text implies an opinion that the earphone broke in 2 days. Okay, so this is something which is implicit in nature. Likewise, there are different classification levels are also for the sentiments, like document level, then sentence level, aspect level. When I talk about document level, whole opinion is actually arrived or derived from the that complete document. Okay. Likewise, there is a sentence level classification where subjective and objective classification is performed on the performed on the sentences, and the sentiment classification is received from that classification. And then there is the aspect levels classification where the aspects are like identifying and extracting the object features. It's not always that as Professor Tuba has said that in the classification, basically you extract some useful features, and based on that useful features, we actually decide on the what kind of class it should be in. It should be placed in, right? Based on that thing, we also can find out by extracting those features to understand that whether the opinion holder, what opinion holder is wishes to express, and what is its polarity. That is what comes into the aspect level classification. Now there are different types of sentiment analysis. It's not it is based on the emotions, it is based on the aspect, it's based on the fine-grained sentiment analysis, where actually the ratings and the reviews are being understood or analyzed by using the AI techniques. Then there is intent-based sentiment analysis also, where the intent of the customers, whether they are looking to buy something or the product or just browsing around, is achieved. That is actually understood by this intent analysis. Many of you now must be seeing that when people go to some any app where you want to purchase, where you are looking for something. Okay, say that you are looking for some particular t-shirts. So when you will go to some social media sites or some other sites, say that you're visiting Rediff, or where you're reading the news also, or you're going to the Facebook and you're reading some post of your friends also. During that time also, those searches, whatever the searches that you have done for the t-shirts, that will come there and that will be flashing on your screen. Okay, they will be motivating you, they will be trying to attract you towards their products. Okay, that sort of thing is based on the intent analysis. So then why this sentiment analysis is important is already I described to you, but the thing is that for the business industries, it is really, they need to understand that what customer is thinking. Okay, so it is very instrumental in understanding the public perception. Even in the stock market also, when somebody is writing about the stock, okay, say that I'm today mentioning that the TCS is, I'm getting a news on as a Facebook post that TCS is having some particular addition to their industry now. So that is attracting, or that is motivating the customers to buy the stocks of the TCS. Okay, likewise, there is another importance is there, or the engagement, that because of the sentiment analysis, the engagement between the customer and the business industries will increase, it will improve. Okay, and second thing is that lastly, the research and development, particularly related to that product or services being offered by that business industries, can be improved. Okay, those products can be improvised, that the services being provided, that can be improvised based on those suggestions, based on those opinions and judgments provided by the customers. So that is why the sentiment analysis becomes very important. And this is my, as an AI scientist, this is my particular opinion today, that the business industry is going to have a major share, or they will be driving high based on the sentiment analysis in the future. The internet service providers like Google sometimes in future will be providing the sentiment analysis to the business industries, and based on that, those businesses can improvise themselves. how does this sentiment analysis works? Basically, there are natural language processing is actually performed on the text or whatever the speech that is being recorded or that has been posted by the customers, and based on that, whatever the text input is there, what is the stop word filtering, negation handling, tokenization, these are different types of the natural language processing that will be provided, like classification, as Professor Puna has said, stemming and sentiment class, those will be used, and based on that, the sentiment analysis can be performed. So it is basically a rule based, where the set of rules are already will be presented there, and based on those rules, this sentiment analysis can be done. Next one is the automatic sentiment analysis, where the machine learning or the deep learning will perform the assessment of the sentiments automatically based on the raw data, right? Either it is a raw data, or you can say that the features will be extracted from that raw data, and then it will be given to a machine learning algorithm. And even in the present today's era, where the deep learning takes directly the raw data, this feature extraction or selection will not be there, and they will be giving you the categories like positive, negative, or neutral. Whatever the opinions is there, they will be exactly classifying those opinions into the these three classes. So this feature of extraction is basically a bag of words and word vectors that say that somebody has explained their opinion in the form of the text. Okay, those text is having some words. So that word embedding will be done there and the word embedding will be performed, and based on that, the features will be extracted. Where these features will be given to the classifiers, and those classifiers will be able to exactly precisely will measure the sentiments in the form of the scores, which will be giving us the final output as a positive, negative, and neutral. So these classification methods are like Bayes methods or linear regression, support vector machines, or deep learning, what is being used today or booming today, right? Sentiment analysis challenges are there as well, because as I told you that the whole document is being assessed, and only one assessment is coming out of that, whether that whole document is talking about positively about that business industry or negatively about that business industry, or there is a neutral opinion about that business industry. So that sort of assessment is being is there at present in the from the sentiment analysis. So this the human struggles to analyze sentiments very accurately sometimes, and that is why this sentiment analysis need to be very what I say need to be very thoroughly again explored, so that whatever the difficulty being faced by the human beings presenting their sentiments can be more successfully understood. Okay, the data scientists are also getting they are creating more sentiment analysis classifiers, but there is still a long way. Right now I have also done some work where what I did that we have predicted the stock, or we have given the opinion about the stock based on the previous data of the stock. Okay, how the trend was there in the past about that stock, as well as we also have taken the sentiments from the Twitter. So those sentiments and the previous data has been actually we have given to a hybrid classifier, and based on that, the opinion about those stocks has been generated. So some of the major challenges regarded to the sentiment analysis are subjectivity and tone. People the text is huge and that need to be assessed. Okay, the context and the polarity, as I told you that the polarity is very specifically right now only positive, negative, and neutral, but more classes or more fine polarities are required to be produced. It's an irony and sarcasm. Then comparisons are there, where the sentiment analysis need to have that comparison. When somebody has derived a sentiment for one particular task, it should also be able to compare it with the other industries, and proper suggestions can be given, or regarding the products and the services. Emojis are coming today because whenever people are expressing their suggestions or opinions, they are using the emojis. So understanding the emojis or understanding the sentiments from the emojis is also a challenging today. Defining the neutral. Whenever as a AI scientist, when I was doing this work of stock prediction, defining the neutral is getting really difficult because it is not always possible that how to decide the neutral. Okay, so that difficulty of the neutral, defining the neutral, is need to be handled very carefully by the AI scientist. Second, lastly, the human annotator accuracy. That somebody, whenever you are designing the classifier or any deep learning algorithm, the annotations will be created. Those annotations need to be accurately and precisely created by the human experts. Those will be helping us to create that ground truth to train our classifiers. So that these are some of the challenges that are still being faced by the sentiment analysis, right? So this is an example where actually the better sentiment analysis is being done, balance aware dictionary and sentiment reasoner. Okay, it is actually based on the text data, where from the text data the sentiment is actually measured. So you can see here in this example here that I am going for a walk. Okay, so this is a sentence and these are the polarities being created here. This is a neutral polarity is 1.0, positive is 0.0, negative is 0.0. Likewise, if I'm not sure about the new design, so I'm not sure about the new design, it means that the neutral opinion is more dominant. That is why the higher values is coming here for the neutral, that is 0.611, and for the positive it is coming 0.218, for the negative it is coming 0.171. Likewise, there is a next sentence, the mobile app is amazing and user friendly. Okay, so it is a positive thing, so that is why the positive score is high. Likewise, the word customer care ever totally dissatisfied with the services, it is giving that the negative polarity is higher. So this is how this particular broader sentiment analysis is giving you the sentiment of the customers based on the text. Okay, this is just an example for the all the present here. So this is all from my side. This is what just I wanted to share with you, that on this inauguration session, I am really thankful to the GR Foundation for giving me an opportunity to share my this knowledge with the gathering here for the ISBM 2022. Thank you once again, and I wish all the success and to the presenters today, and I wish them a great time in the ISBM 2022. Thank you so much.
Thank you, Professor Londe, for your address and the knowledgeful presentation. As we are experiencing this in our life, this definitely gave us a clear understanding and knowledge about the sentiment analysis. Thank you, sir. Moving further, next we have Professor Chakchai So-in. Dr. Chakchai So-in is a professor of computer science at the Department of Computer Science at Khon Kaen University. He received Bachelor in Engineering and Masters in Engineering from Keset Cert University, Thailand in 1999 and 2001 respectively, and Master of Science and PhD from Washington University in St. Louis, USA in 2006 and 2010, all in computer engineering. In 2003, Dr. So-in was an internet working trainee in a CNAP program at Nanyang Technology University, Singapore, and obtained Cisco Microsoft certifications in 2006 and 2010. Dr. So-in was an intern at Mobile IP Division, Cisco Systems, WiMAX Forum, and Bell Labs USA. His research interests include mobile computing, sensor networks, Internet of Things, computer wireless distributed networks, cybersecurity and intelligent systems, and future internet. Dr. So-in has authored and co-authored over 100 publications and 10 books, including IEEE, JSAC, IEEE Communication, Wireless Communication magazines, and computer networks. Professor Chakchai So-in, Welcome to the session, sir, and over to you for your further address.
Okay, good morning, afternoon, and evening for everyone. And also Professor Chuba and Dr. Lonnie. And thank you, Anisha, for nice introductions. And thank you, Dr. Amit, who invited me to give a talk today. I try to make it brief. I'm Chakshai Soin from Content Universities. And the today talk is about AIoT, what it is, and the benefits to the business domain. So let's talk about AI. I think most of you are familiar with the AI. So just to make it in brief. So AI basically is a system or machine that tends to simulate the human intelligence, basically making a machine smarter. So there are many AI applications, and as the other people already said about that, classification, clustering, or etc. The three classical techniques includes fuzzy logics, just for the reason purpose. In the real world, there is not just right or wrong, 0 or 1, but it's the real numbers. So to give an example, in a restaurant business, suppose you want to give a tip to the waiter or waitress. If the food is good and maybe the service is not that great, how much you're going to give a tip? And in opposite, if the food is not tasty, but the service is perfect, then you may prefer to give more tip. Neural networks, just for the matter of learning, it tries to imitate the human brains, so we can learn basically. And similarly, the machine can be trained and get a specific pattern, building the model with error and success to tune up the probabilistic weights. Evolutionary algorithms, for the sake of optimizations, is inspired by biological evolutions, including mutations, crossover, selection, and the fitness is used to determine the quality of solutions. So now you know AI in brief. And next, what about machine learning? A subset of AI, basically, it made the machine learn by its own or self-learning. And deep learning is basically a breakthrough for past years. It's a subset of machine learning, but a bit different. Here, the deep learning allows the machine to be trained by exposing several layers with big or huge data, and that needs high power. So the figures below are good examples. So let's talk about the first sorting system using image. So we try to sort banana, orange, apples with machine learning. We try to get a definition of what each fruit looks like, say feature extraction, attributes and features will be used to create a blueprint like color, size, shape, and then put them to build a model as training. And finally, classify the fruit accordingly. Talking about the deep learning here with a lot of inputs, different from machine learning. Now there is no need for explicit feature extractions. We let the model do it. We build up the patterns of what each fruit looks like, and with classifications in several layers to finally identify the fruits. Here, there are three machine learning techniques: supervised, unsupervised, and reinforcement learning. So the supervised ones, as the name says, we need to elaborate, say the answers used to map from input to output as classification and regression are the two examples. As opposite with the supervised, the unsupervised learning is self-learned. There is no need for training. The three key areas are clustering, association, and dimension reductions. The picture here are good examples. The clustering itself, we do not know the answer, and we'll try to get some sense of relationship or similarity with features, characteristics for each group, such as the similarity between the dog image and cat image, and then find out the separator between those two classes. For classifications, we need to know which is the dog and the cat from experts, and then get a set of features to represent each class, and feed them to the model as training. The testing will determine if the new image is adopted accordingly. So next, the reinforcement learning. So we basically aim at maximizing the rewards for the actions. The two key areas are decision-making, reward systems. So the machine here attempts to do several times of operations with trial and error interactions, and finally determine if it's right. The figure here is a good example again. Suppose there is a dog trainer. I want to give the dog say sit. So he commands the dog observes. The dog will then respond by an action. If the action is close to the desired behavior, the trainer will give the reward, like food or toy, and otherwise none, or giving a negative reward. The process keeps on going, and finally the dog will sit eventually. Many machine learning algorithms, and thanks for the DataCube Thailand to make this summary. I won't go into detail. For example, naive ISBM are used for classifications. Many types of regression are used in business domains, such as stock market predictions. Okay, let's talk about the example to apply the machine learning in business. So regression is one good example, which is used to explain or predict some numerical values using historical data, like time series. Most of you are already familiar, such as simple linear regressions, making a line fitting, or a plan for multiple ones. So one good example is in the restaurant business. The manager wants to minimize the waste when he must buy a lot of ingredients or products. In particular, those can be sold or it may not be fresh anymore. Here, the inputs may be the daily use of ingredients or products or even the holidays. The number of customers historically, typically from week to week, month to month, it follows the similar trend. Unless it is an extreme case like a war or something. So now we know what to buy. So now you know AI, machine learning. What about IoT? I think Internet of Things. I think all of you know about Internet, connecting the computers, going online, etc. But IoT is used to connect things. We connect things, not just computer, but phone, watch, car, meter, and many kinds of sensors. So to determine the things, we need to address the things. So thanks for the IP address and RFID, so we can make things to think talk, like machine-to-machine communications. To make it in brief, there are three main components, like the humans. The human has eye, ear, mouth, skin, to get some sense of environment all around. And we need to think, interpret this sense, and may also want to talk to other people. Similarly, the things or sensor or IoT device, we perform a sensing task for environment such as humidity, temperature, vibration, and image. The thing also needs to compute like pre-processing, aggregations, but in an efficient way, because most of the things are small, tiny, with energy limited. And the sense data will be transferred to the other end, such as clouds, for further processing, such as for the purpose of analytics. And that is why the AI come in. We'll talk about that later. Just to summarize, we can say that IoT is a new revolution to connect the smart things. And currently, just a few things are connected. But in the future, tons of them, refrigerator, rice cooker, air conditioner, line car, and many more will be connected. I also grabbed this figure from the research and market. Last year, the market cap was like 300 billion US, but the forecasting in the next 5 years is around 4 times as much. So it's always open for you. So now you know about AI and IoT, and here is the bridging between them. As said, the IoT will bring a lot of tons of data to the internet. Although the data may not be always good, then AI comes in. Here, it's try to assimilate or evaluate the data, or even make a precise decisions for the things. So we can say we make things smarter. And machine learning with IoT here, we try to get some sense of patterns, or we can also seek a useful information from tons of data, or even to detect any faults of the correction process. With those, we can make operational forecasting much faster and higher in precision. The figures below are good examples. Previously, we have just a traditional plug, mostly off and on, but now we have a smart plug. So we can do some remote or wireless control off, on, set up the timing, and with AI, we can correct the power consumption and do some analytics to see the trend for prediction purpose, or even decide if the circuit will be broken down or short. Next, a watch. Previously, we can only see some sense of what time it is, but now we have a smartwatch. Not only there are a lot of mobile applications built in, making a call, gaming, banking, but now the watch can also even do the blood pressure or heart rate detections. With AI, there is ability to detect an alarm if something may not be right to your health. So let's focus about the benefits of AIoT in business domain, as already said briefly. First, business analysis. So you know what you need in advance. For example, in the retail business, like stock control, AI can be used to get a precise equilibrium between supply and demand. Next, the productivity is increased, in particular in automation business. Now we have a robot IoTs used to replace some time-consuming jobs, and AI is used to find the proper settings, eliminating the downtime to avoid the machine failures. It is a huge loss in a manufacturer or factory. A simple example is the predictive maintenance. So we do the maintenance before the actual machine failures. So next, we can make a better product or service, or making the user happy. For example, in the logistics domain, Amazon provides a faster or more convenient way to deliver a product like a drone, better customer experience. And now we have NLP, natural language processing. This is to make a better communication between people or machine. Chat, voice bot is also a good example. Recommendation is with us for a while, trying to suggest what you may want to buy, such as Shopee, Lazada, Facebook. They will basically pop up or give you some sort of what you may want to buy more and more. Oh, well, actually today is 9/9, right? I just bought a lot of from the Shopee or Lazada with that suggestion and obviously discount. Finally, to improve the protective measure related to the security in the banking domain, AIoT is used at ATM. Camera, motion sensor can be used to feed the information for analytics and help the system to analyze the potential illegal behavior. So although AIoT is essential to the business, but there are always a challenge. I just want to point out a few key things. First, the data. Even though the more the data, the better. However, aside from unclean data, the data in general is not structured. So we don't really understand the data. So we may need to have some sort of the pre-processing, training. We also need the domain expert to identify the outcome. For example, how much the vibration is to make the machine fail. Training AI, since there are many AI applications, so there is no single model that fits all. So AI can also be biased with the set of the seed of data. We also need to rerun and retrain over and over with high precision required to make the right decisions. Next is relating to the timing. In other words, real-time decision. Some applications do not work well with time-consuming tasks, like in the training or testing. We need to act or react instantaneously. You cannot just send the information to the cloud, it's too far. So you may need to make it closer, like a fog or edge computing, to lower the delay. 5G also brings many advantages. In particular, the short delay or short latency in autonomous car business. For example, the latency of the decision to actually brake should be low enough to avoid the possible accidents. Okay, I think let's talk about some of our research and application. Just point out a few things, right? So this research is basically relating to the location or positioning. So the problem is as follows. In outdoor, GPS is generally used, but not in indoor. or even the underground. For example, where we are or what direction you should go in the big shopping mall in the airport. In particular, with the existence of obstacle like a wall or a door, that the signal is unstable. So our solution is to imitate the satellite structures. So but here we use a radio signal from the access point or Bluetooth, and from our observation. So we use the fuzzy logic based on centroid for a low node density scenario and the extreme learning machine for the opposite. So then we hybridize them using PSO to tune up the approximate positions. I think detail can be used, can be just find out from the ASOP paper if you want. So here's a simple example of our applications. So what we have here is the collection and prediction platform of PM 2.5. I think everyone know about PM, in particular Bangkok here, is not for good for our health. So what we build is a portable hardware box to get the PM 2.5 and feed it into the cloud wirelessly. And the cloud do some analytics for forecasting purpose based on the historical data. Here we have two boxes. One portable one is used to mount into the motorcycles, since there are many of them all around in Thailand. And the other one is basically on the rooftop. In the rooftop with the solar charger and built-in wind sensor for flow directions. This will also fit into the analytics. Okay, let's see a bit about our demos. Okay, here, I'm sorry that this is a Thai menu, but this is a box. So we build the hardware box. Basically, there are GPS, controller, Arduino, and sensors.
Sorry for the interruption, Chakchai. I think so your screen is not visible.
So you can see my screen?
No, you can just share the screen actually.
Oh my. So you see that you don't see my screen for a while or something? Oh my God. I'm sorry.
Technical schedule is the shown, so the presentation or something is not shown yet.
I see. Can you see my screen now?
I think so that different screen is there. Yes. Now I think so there is a bit.
Very sorry then, sir. Okay, anyway, I'll try to wrap up. Okay, I think this is our application. So basically, we build the platform to get the PM 2.5 all around the campus. So we get the sensor in real time, and we make the hardware mount into the motorbike, right? And here we just move around the campus and we get the data in. Yeah. Okay, and then we can basically, I think we have a service. And if you just load the line application, you can see what is the PM in a particular area, or even we can get some sense of what about the future PM 2.5 by using the analytics. Okay, let's see. Right. I think we missed a lot of the I'm sorry. Anyway, the technical issue. Anyway, I think it's done off my slide, and I think you know AIoT is a present and future applications to connect the smart things. There are key value of the business, the predictions, the forecasting, and many more to boost up the business operations. But again, with concerns. I mean, how good it is, accuracy, precision. I mean, in real time, decision, latency, energy, or AI power. And obviously, we need the model customized to meet the application specific. And we're looking for the future application. Sorry again. And thank you. And I'm happy to answer if you have any questions. I'm sorry again. I think okay. Thank you, Emil. Thank you.
Thank you, Professor Chakchai Soin, for your knowledgeful address. Moving further, next we have Professor Nilanjan De. Nilanjan De is an associate professor in the Department of Computer Science and Engineering, Techno International, New Town, Kolkata, India. He is a visiting fellow of the University of Reading, UK. He also holds a position of adjunct professor at Ton Duc Thang University, Ho Chi Minh City, Vietnam. Previously, he held an honorary position of visiting scientist at Global Biomedical Technologies, CA, USA. He was awarded his PhD from Jadavpur University in 2015. He is the editor-in-chief of the International Journal of Ambient Computing and Intelligence. He is the series co-editor of Springer Tracks in Nature's Inspired Computing, data-intensive research series, co-editor of Advances in Ubiquitous Sensing Applications for Healthcare. He is an associate editor of IET Image Processing and editorial board member of Complex and Intelligent Systems, Springer. He is the Indian ambassador of the International Federation of Information Processing, Young ICT Group, and senior member of IEEE. Professor Nilanjan De, welcome to the session, sir, and over to you for your further address.
Thank you very much. A very good morning to Professor Tuber, Professor Soin, Professor Londe, Professor Kothari, and all Amit, and all the GEAR Foundation members, and all the participants. Let me share my screen. So it will be a brief talk of 10 minutes. So in this particular talk, I will try to focus on that how data is important for machine learning. So if there is a crunch of data or the size of the data is very small, then how it works for the machine learning algorithms. Now, initially, if you think any machine learning algorithm, the intrinsic nature of any learning algorithm is it always very much depends on or very much sensitive to the data which you are feeding for the training purpose. Now, the problem is if you feed garbage, then the output will be automatically garbage. So it's not always the more number of data, rather we should focus on good data. And now before going to good data, what is bad data? Bad data means inconsistent data, maybe missing data, redundant data, contextual data, or garbage value. These are all so-called bad data. Now, if you train your system with bad data, ultimately it will be a disaster and the entire model will be negatively predicted. So if you go for a proper model, it's not always we should focus on more number of data, rather we should focus on more number of good data. Now, good data looks alike, but bad data are bad in their own way. So all different bad data, their characteristic you have to understand, and we have to judge based on the assessment. We have to tune it, we have to rectify it. So that's why good data is always good, but bad data, we have to correct it in a proper way. Now, how much data is good for any machine learning algorithm? It's a very common question that is there any proper heuristic mechanism which tells you that this much amount of data is good for machine learning? Technically speaking, there is no as such algorithm which tells you, or heuristic mechanism will tell you that much amount of data you need. It's always as much as possible data, and that data needs to be clean data. Now, deep learning algorithms are basically a memorization technique. So it's a kind of model of interpolation. The major lacking of any neural network system is it doesn't understand the underlying pattern or underlying behavior, or maybe you can say the relationship in between the variables. So once there is a missing component, that means the absence of relationship building in between the variable is missing, then what you need to train your system with lots of variable data. So until now, I was talking about more data, more good data. Now I have to think about more number of good variant data. So as much as possible variable data you can provide to your training mechanism, you will see you will be able to overcome those limitations. So to cover all aspects of variations, we need to train our system with lots of variable data. Now, the deep learning algorithms, they are far away from integrating the abstract knowledge. We don't actually focus on what the objects are or what they are for or how they are typically used. We are more emphasizing on getting the results rather. So the abstract knowledge is a missing part. But if you look into human being, you will see a 7-month-old infant. He can also understand or try to find out some rule, maybe from some unlabeled data set within a couple of minutes. So, but for deep learning, the major lacking part is the abstraction, the verbal definition, the missing part. So that's why we need sometimes millions and billions of data. So ultimately, the question comes that how much good variable data is enough for machine learning models? Now, let's think from the traditional machine learning point of view or shallow machine learning point of view. Suppose there is a single point and you are trying to fit a polyfit curve. Now, if you increase more number of points, you will see automatically the curve will getting smoother. That means it is getting better generalization. Now, if you try to increase more and more points for linear regression, more number of points gives you more prominent point estimation or improved point estimation. If you go for KNN, you will see the prediction classes, it will change actually based on the, depending upon the number of data points. Even for the splitting of any hierarchical structure, where also maybe the tree structure, you will see no more number of data points actually tells you that it gives you different result. So these all splitting or the predicted model, everything actually depends upon more number of data points. So as the number of data points changes, the generalization will be much, much more better. But what's wrong with small size data? Because if the training data is very small in size, actually it always revolves around a high variance. Now there is always a chance of overfitting, because if you're trained with system with a very less number of data, there is always a chance that it should get overfitted. Another thing is outliers. If there is very less data, there is always a chance that the data is a noisy data, which is very common data. I mean, cases. In real life scenario, you will see there are lots of noise or perturbated data, which is very common data. Now, here the outlier plays a significant role. It's very dangerous, because if the data size is very less, then the outlier plays a significant role, a dangerous role rather better to say. So that's why small size data we have to, deal with in a different way. Now, back into the history in 2009, Professor Lee from Stanford University, they come up with a huge data set called ImageNet, which is a widely used data set where there was 14 million different hand annotated data of 80,000 different categories. So you can imagine 14 million data with 80,000 distinct categories. So initially, during the period of shallow machine learning in 2010, the error rate was 28%. But once AlexNet introduced, deep learning models introduced, it becomes 16% initially in 12. Now gradually after 2014, the error rate getting lesser and lesser, and it's below the human error rate. Now it is almost reaching 1%. So you can imagine how we are improving last 10 years or 12 years down the line. All the deep learning frameworks comes one by one, and there is a drastic changes in this, accuracy models. But the problem is how many numbers of different parameters you need to tune. I'm forgetting about those 80,000 distinct categories. Professor Hilton in 2012, he reported that if you need to go for 1,000 categorization, you need to tune 60 million parameters and 6.5 lakhs of nodes. So imagine you are tuning 60 million parameters and 6.5 intermediate nodes in a neural network. It's unimaginable. I mean, the complexity is too high, and it's only for 1,000 categories. And I'm talking about 80,000 categories of Professor Lee's those benchmark data. So you need millions of data need to be tuned. You need lots of hardware infrastructure and lots of data. As the model size increases, the data size increases, the complexity of the problem domain also increases. So yes, it is always good to invest more time and money to gather more data. Now, what's wrong with small size data? Suppose the field is a healthcare data. Now, once for the doctors, hand annotation or benchmarking is a very time consuming job. They generally not prefer to go for benchmarking manually. Or every country, they have different patient privacy laws or data privacy laws. And for the chronic disease, getting data is always challenging. So in medical data, getting medical data for these all different constraints, it's always hard to get. Now think about it, if we are getting say 500 MR or say 1000 CT images, we are happy with that. But one side we are dealing with 14 million data, and other side we are talking about 1000 data. So getting data is important, but it is, important, and getting is a difficult always task. Now think about questionnaire-based survey. Now, once we are doing for any questionnaire-based survey in management or somewhere, you will see we are happy to collect, say, 377 numbers of samples. Means it's a kind of sample size calculators, which from where we can predict a population of 20,000 people. But 377 is a number from where you are coming up with a generic, rational decision for 20,000 people or population. It's a kind of, for machine learning, it doesn't make any sense. So the data augmentation is a very primitive technique like geometric transformation. You need to rotate, translate, and flip, or maybe go for stretching, sharing, maybe deformation, maybe contrast augmentation or color augmentation. These all gives you multifold images. So from a basic image, you can create n number of images. Or maybe some other techniques like random erasing, mixing the image, or blending the images, or going for filtration, means kernel filtering kind of stuffs, where you will see from one particular image, you can create another, say, 10 folds or 12 folds images. But the problem is all those 10 images or 12 images actually coming from the base image. So somehow this particular technique is, this image manipulation technique is biased. So once you have biased technique, we should go for some other deep learning mechanism, like say, for example, GAN. So GAN is a kind of image-to-image translator where you are changing one particular scene to another scenario, like for one winter to summer or summer to autumn. Now, particularly GAN is a very complex model. It's computationally intensive. So we need a cheaper solution. And for the cheaper solution, one solution is neural trial transfer, where we used to change the texture, ambience, appearance of a particular image so that, we can create more number of synthetic image. Now, as per GAN, GAN is a kind of, almost everyone knows that there are two different modules. One is the generator and one is the discriminator. Generator creates the fake images. Discriminator always try to, find out that is the image which is sent by the generator is a fake image or it's a real image. So it gives a probability that it is a fake or it's a real image. Generator always try to create more and more realistic image, and discriminator try to not getting fooled from the generator. So in this way, there is a tussle. So there is a Nash equation given by Professor Nash, where based on that, there is an optimization problem. Ultimately, once a discriminator not be able to detect that it's a fake image, the image passed through the discriminator. So it gives you synthetic data. Now, neural trial transfer, as I already said, it's a kind of changing the texture, ambience, appearance. You can go for multifold creation of synthetic images also by neural trial transfer. And another way you can change or you can increase your data size or solve this problem by transfer learning, where there is a known huge set data from where you are trying to extract the features. Now, if you have a problem particular domain where the number of feature is very less, you are not trying to find out the less number of data, then what you will try to do, you will solve an unknown problem where the data is available. You pass that knowledge as a frozen knowledge to another particular module and try to solve a problem called B, where there is a crunch of data. So in transfer learning module, what we are trying to do, we try to solve a problem called B by solving experience of prior experience of solving A. So it's a kind of transfer the frozen knowledge, or you can say it's a kind of pre-trained model. Even though transfer learning widely used, there are one reason is, you can say it's a heavy computational resources required, but the parameter tuning is very less. So that's why transfer learning is widely used. So even, in fact, in GAN or neural trial transfer and the transformation learning, these all are a technique which actually helps you to go for synthetic data generation or augmentation. Lastly, in 2012, Google actually come up with a flu prediction model for flu outbreak. And in 2015, it actually, Google reports that the size was almost double. So it's not properly predicted. So these are one failure model. It's very difficult, like during the COVID period, during say, I'm talking about in 2021, February, March, that period, there's a very crunch of data, and based on that data to come up with a prediction model was a very difficult and challenging task. So big data hype is a kind of, say, you can say it's a automated arrogance kind of stuff. There is a good book written by Martin. Martin actually wrote this book, this Small Data. Interesting line is over there. You can go through that particular book one time. The small data is a foundation of breakthrough ideas or completely new ways to turn around the pants. Thank you very much. So if you have any query, you can write through mail, you can talk over mail. Thank you very much. Hello.
Thank you, Professor Nilanjan Dey, for your knowledgeful address. And it was a sheer pleasure for all of us to listen to the speakers. Now that we have come to an end of this inaugural session and we have different technical sessions planned for the day, I request all the participants who have been attending the session over the time to kindly attend those sessions. Further, it's a request to all the participants to join the technical session as per the schedule. The timing for the technical session 2A is 12:30 to 2 p.m. and for the technical session 3A, it's 3 to 4:30 p.m. at Bangkok time. We will start the sessions within next 10 minutes. Each session will be delayed by 10 minutes. So kindly join your sessions accordingly. Further, I sincerely thank everyone for their valuable presence in this session. It is our pleasure to have you all here with us, and we will be happy to have you in the second version of this conference in 2023 in physical mode. Now, I request you all to please switch on your cameras for a snapshot of this virtual session. Okay, thank you so much, everyone.
Thank you very much.
Once again, thank you very much to everyone who is here, and I look forward to see you sometime physically next year in 2023. And special thanks to Dr. Chakchai, Dr. Tuba, Dr. Narendra for joining this session, and Dr. Dey specifically, who is also the TPC chair. Thank you, and look forward to see you over the technical sessions.
Thank you.
Thank you very much.
Thank you. Thank you.
Thank you, everyone. Thank you very much.
Thank you.
Thank you, Dr. Chakchai, and look forward to see you next year in person.
Yeah.